This is Bitcoin. Now, Bitcoin is a decentralized cryptocurrency, meaning that it's not really anything physical, and it's not regulated by anyone. So it's basically democracy of currency at its finest, to put it simply. So Bitcoin is stored in cryptocurrency wallets, and these wallets can be quite interesting once we get down to the details. Now, Bitcoin in particular uses a elliptical curve, I believe it's called, but this is a real name for it. Now, I'm not even going to try to pronounce it or anything like that because I'm pretty sure it's just an abbreviation. And I'm going to be quite honest with you, I'm not exactly quite sure what all goes into it. I just know that I have successfully made a cryptocurrency wallet. And today I'm going to be showing you how to in the Java language. Now, I will be copying and pasting code and using external libraries, but you can feel free to go down in the description, take a look at the code, and modify it however you choose. But with that being said, let's go ahead and get into this. So for the first part, we actually need a library called Bouncy Castle, and this is basically going to be where you get all your cryptography stuff at. So let me go ahead and put this in. This is going to be the repository right here, and our dependency is going to be this. So let's go ahead and create this. We're just going to format that and clean it up. So this is going to be our dependency for Bouncy Castle and our repository. And let's see if there's anything else we need. That should be it. Yeah, and that's all we need. So I am using Maven. This is just to kind of help with importing stuff and managing my dependencies, and makes building the project a lot easier. But as of right now, I'm trying to build this project. It messes with the signatures and you're not able to run the jar properly. But again, my code will be open source if you guys want to go check it out, modify it, clean it up, or even if you find the solution to my problem, feel free to add a push request. So let's go ahead and make the main class. We're going to do a package called proj.key.gen, and inside here we're going to make a main class called key generator. Alright, and then we need to make our main method. Public static void main string array args. Alright, and we're gonna have a few spaces in there just to make it kind of cleaned up. So with this being said, what I want to start doing is we'll need to add our provider for Bouncy Castle. So we're gonna do security dot, as soon as this loads, give it a minute. Okay. Oh, it was there, I promise. Add provider, and we're going to do a new Bouncy Castle provider. And then we're just going to import it. But I did probably spell that wrong, so let me check. Oh, maybe that. Import. There we go. Okay. Alright, so now that we have that imported, this is where we're going to be getting our most of our algorithms for doing our key pairs and hashes and all that sort of stuff. I will also be using my own base 58 encoder. It's gonna, like I said, it's still gonna be in the project, link down below, so you can just go in there and copy that, or you could use your own. So let's go ahead and let's generate our keys. So first thing we need to do is we need to generate a key pair. Let me figure out how we did this. Okay, so the first thing we're going to do is we're going to do key pair is gen keys, that. So we add a method down later that'll help us with that. Then we'll do a string private, sorry, we'll call it priv is equal to get priv. We're gonna pass in the pair object, the key pair object. And we're gonna do string pub is equal to get pub. We're gonna pass in the pair object there as well. And then later we'll do sysout. We'll do priv. We'll do sysout pub. And just so that we know which one's which, we'll do private key. And here we'll do public key. Alright, now let's go ahead and get started on our key pairs. So these are going to be static methods, since we're kind of doing, it doesn't really rely on instances, so it doesn't really matter. Let's just go ahead and get into it. So we'll do a public static key pair, gen keys, like we said earlier. And this will throw an exception. But we're going to catch that in the main class, or the main method, so we don't really have to worry about that. Before we do the return, yeah, I'm just going to paste the code in here. Well, then we'll do return keygen dot generate key pair. So basically what this is doing is it's telling it that we're going to be using the elliptical curve key pair generator using this algorithm, and this will basically show us like what we were talking about here earlier. It's going to be this one. So from what I've been reading is that these private and public keys are basically like points on this line right here, and they're hashed and encrypted and encoded and all that stuff. That's as far as I can tell. But again, I'll be linking all these pages down below in the description, so you can go read up and educate yourself if you'd like. Mostly the reason why I'm doing this video is because there's not really any resources out there that show you how to do this properly. So this is just kind of like a quick tutorial on how to do something like this. So next thing we're gonna have to do is we have to get the private key. So we'll do static string get priv Alright, now let's go ahead and do this. Now before we do the code for that, whatever string this prints out, our method is going to print out, we'll need to adjust that to a 64. I believe it's 64 bits. So let me do this method right here. This is going to adjust our string to 64, and then we can go ahead and continue on with our private key. So let's do this. I'm actually going to type this out so you guys can follow along. So we'll do return adjust to 64. I'll put colon there. And so inside here, we're actually going to cast something. Alright, so we're going to do EC private key. We're going to import that real fast, see if it'll let us. No? Okay, we'll just move on. We'll do pair.get private. And outside here, in this private key, you're going to want to do the Java version. So get privates, and then outside of the private, we're going to do .get s, and then we're going to do .toString, and the regex is 16. So this will return our private key string. And again, we just passing it through this method, just make sure it's 64 bits or bytes. I believe it's bytes. Yeah, it's bytes. And then the public key is going to be a little bit more involved. So all I'm going to do is I'm just going to copy and paste from code I did earlier, and I'm going to paste it in here. I'll give it just a second so you guys can pause the video and type it all down. And then we'll go from there. Let's do public static string get pub key here and paste. So I'm gonna pause right here and we'll get to the rest of this code that's outlined in red here in just a second. Alright, so now this is where your base 58 class comes in. A lot of people ended up using these resources. One thing that you can use is called Bitcoinj, or Bitcoinj, I believe it's called. That has a base 58 class, which is basically what I'm copying now, but I had problems importing it. So I actually ended up creating my own class. And this just took out bits and pieces that I needed from the original class. So this code is from Bitcoinj. So I'm not taking any ownership of it whatsoever. And I will as well link that down in the description as well for you guys to check that out. So let's go ahead and do new class. We'll call this base 58. And we're just going to copy there. Alright. So this code, make it a little bit cleaner. Boom. There we go. I like to add a little space here. Alright. So this is going to be our base 58 class, and we'll refer to this here in just a second. So let's import, so I add exceptions right here. Now usually you'd want to specify which type of exceptions. I'm just doing this to make the code cleaner and get on with this tutorial. And let me make sure we've got everything. Throws declaration. I guess we need to do a try catch here. So let's do X. We'll do try catch exception E. We got print stack trace. And then here we'll paste our code. Do this, do that. Save it. Import everything, save it again. And that should do the trick. Yep, that should do the trick. Alright, so basically what we've done here, we're just going to do a quick run over. So we're trying to create our key pair. We get our private key, and then we get our public key. Now the public key is a little bit more involved. As you can tell down here, you have to do double SHA hashing algorithm and add a check onto the end of the public key, and just a couple of other things. Let me see if I can figure it out. So this is where we hash it twice, and then down here is where we add the I believe it's first 4 of S3. Yeah, so right here is where we add the first 4 of our second hashed public key to the end of the original public key, and this is going to be our checksum, or our hash check. And that way the next person that, or the next program that goes to decode this public key will know whether it's a valid key or not, or if there was an error or something like that. So here's where I was talking about the 2 points, right here I believe, and over here we're just doing a couple of again, more hashing algorithms, and I'm actually not sure what this is. But anyways, like I said, you guys could read up more on your own. I'll leave the links in the description, like I said before 1,000 times. So let's see if this works. So we're going to do the key generator. I'm going to do this run configurations. sorry, I didn't mean to do that. Run as Maven build. We're gonna do, what am I doing? Don't save that. We're not trying to build it, we're trying to run it. Run as Java application, that's what I want to do. Alright, sorry about that. Let's see, key generator. So we're gonna find a main class, we're gonna click OK, it's gonna run, and it's gonna outprint our private and public keys. Now this is gonna be our private key. We can add this to any of the any wallet application you want to. It's not in wallet import form. It's just in base 58 form. And then here is going to be our public key. So if we were to take this, actually, let me do this real fast. A little trick for you guys. So blockchain, the one that kind of monitors and runs blockchain, if I find it, they have an API system set up where you can check to see the balance of a public key. And so if the public key is created incorrectly, this website will let you know. Let me show you an example real fast. So if we were to do this, and we were to take our public key here, right? So if we were to do this, take a public key, paste it in there, it would show that there's a balance of 0, because no transactions have been created to this private address yet. Now with that being said, if we were to change this G to an F, it would say that the Bitcoin address is invalid. So knowing that we actually did create the Bitcoin address correctly proves that this is a proper Bitcoin address right here. So this can be used anywhere that you'd like. And if you want to as well, you can even use this blockchain website to get the wallet import format of your private key. So just paste whatever private key that you generate into it, and it'll the next time you go to see your private key, it'll give you the wallet import format, and you can use that however you want. As for right now, this is the private key and this is the public key, and you could use this on the blockchain however you'd like. And I believe that is it. Now I did create a bit generator which will create constantly new private Bitcoin addresses and public addresses, and if it finds a balance, it'll save it to a config file, but the chances of that ever happening are basically none. So I wouldn't, I mean, you can do it, but it's gonna be kind of a waste of your time. But anyways, that's how you create a private and public Bitcoin address in Java. All the code, all the information, links and stuff like that will be down in the description. And I hope this helped some of you guys out there, because everywhere I looked I couldn't find anything to help me do this. Anyways, I'll see you guys later. Thank you.